Good afternoon at Lindum on a sunny Tuesday afternoon. It is almost 12:28. We've got 2 minutes, and we're going to show you a little bit about how we test for pallet stability, and we're going to talk for a minute or two about why that's important. While we're waiting, Patrick, if you could just open that door for Luella, that'd be great.
No problem.
Yeah, we've been looking forward to showing people our test lab, which we've got behind me. It's been an interesting journey. We've had this lab for about just over 12, probably 15 months now, and it's taught us more than we knew that there was to learn about pallet stability. So it's been a very interesting journey, and we're just going to share with you now a few little tidbits about pallet stability and how testing fits in with the process of making pallet stability improvements. So I think we are almost on time. It is 12:29. You see, Emily, have we got people logged in?
Yeah, I've got a few.
That's good. Looks like we've got lots of people on. It always amazes me what high level of interest we get from different people in the food and beverage industry about pallet stability. It's a not very much talked about topic, but a critically important one. So with that, it's 12 o'clock, and we're gonna show you our test lab. So welcome to Lindum, and welcome to our pallet stability test lab. So what we've got here is a mobile pallet stability test lab that is testing on pallet stability to UMOS standards. Now UMOS is a European standard on the level of stability on a pallet, which we're going to go over. But one of the key things we decided to do was make our test lab mobile. You can see it's in a truck. Patrick, do you want to just touch on why we decided to do that?
Yeah, so I suppose one of the main benefits of the lab being mobile is that we can, of course, go to customer sites and perform the testing in their yard, if you like, with their pallets coming straight off the production line and loaded to back in this testing lab, which we can then perform the UMOS testing on. And I suppose this cuts out the stress and strain of transportation, so we can perform the testing as the product is straight off the line in the best condition, if you like, possible, to give the most ultimately the fairest test performed for the UMOS testing. So yeah, I suppose that's one of the main benefits, isn't it, of it?
That's good. And I was told a story the other day by a client we were doing some pallet stability testing with. He tried sending pallets from the UK to a remote lab in Europe, and they'd had all sorts of trouble getting their pallets through customs, and it had caused them massive headaches. So it's another reason why it's easier to actually bring the lab to your site in the UK to do testing directly off your wrapper. So come with me, I'll show you about, first of all we're going to show you how we load the pallet on and where we start on the pallet stability test. So come with me. So here we're at the back door of the test lab. You can see we've preloaded a pallet here. We've got a pallet, I don't know whether you can see it on the video. We've got a pallet of beer. It is still intact, no beer has been consumed, because we wanted to show you a test with a complete pallet SKU. So our pallet's loaded, and these doors will then be closed, and we'll go around to the other side, the pedestrian entrance, to perform the test. Because for safety reasons we're going to put this through a dynamic load, so we'll actually be moving this pallet, and for safety reasons all doors must be closed while we're running that. So we'll start by closing the doors. And so that's that side of it ready. And what we're going to be doing is we're going to be putting this pallet through a 0.4 G-force test, and we'll explain to you what that is. So this is the pedestrian entrance to the test lab. So come on up, I'll show you what we've got inside. So we're now inside the laboratory, and here is Patrick just preparing our pallet for the test. But go on, Patrick, you explain what you're doing.
So yeah, I've just been putting the labels on. So it's actually one of the main ingredients for the UMOS testing we do here. So we have a label in each corner of the product on the pallet. So the top left, top right, bottom right, and top. And then we have a label on the actual base of the pallet itself, one on each side. And then this camera here will pick up from the labels the movement of the pallet, so it will measure sort of the distance between the two labels, and as the pallet moves, it will measure the distance between which they expand and come back together, and that will then run the technical analysis of how much the pallet has moved, the percentages, how much the product has moved on the pallet, and all the data we need to put into a report for the customer. So.
That's good. So, as Patrick's just touched on, we are testing this pallet for three things. So we're putting it through an emergency braking situation. So if you picture your product on the back of a truck and the truck driver has to hit the brakes, we're putting it through those same G-forces. Now, a point I was going to make earlier and just forgot. This pallet we've got on here weighs nearly a tonne. And if you imagine nearly a tonne of your products on a pallet, on the back of a truck that's doing an emergency stop, in many cases the stretch film that you have put on that pallet might weigh as little as 120 grams. So in reality, what you're doing is you're trusting the safety of nearly a tonne of your products to 120 grams of plastic. And that's why this test lab is important. To make sure that we are achieving the safety and to make sure that we are being as environmentally friendly as we can be, and to make sure that what we're doing is the best for the customer in terms of CO2 cost and safety. So we're going to now prepare this lab for the testing. Patrick, if you want to come through here, we need to close that door. So we have a control panel here. So I'm going to bring the pallet towards me, and the test will be performed in that direction. So it will start with an acceleration, and then at point of maximum acceleration we'll then decelerate it to a set G-force. Now we're going to put this through a 0.4 G test. Patrick, what's 0.4 G?
So 0.4 G test is the equivalent to 40 kmh, and which is also the equivalent to 25 mph. So that's a truck performing an emergency stop at that speed, and that's what this is replicating as it shoots down on the sleigh, shoots down the truck.
So that is emergency stop from 25 miles per hour. So you think about a child running out in front of a truck, jams on the brakes, 25 miles an hour in town, that could easily happen. This is the forces we're just about to put this through. And we often get asked the question, does the bench on this test lab actually get to 25 miles an hour? No, it doesn't. What we're doing here is we're replicating the same G-forces, so 0.4 G, that the pallet would experience in that emergency stop scenario. So in reality, the bench will go probably 8 or 9 miles an hour, but it will stop much quicker than the truck stops to replicate the same G-force. I trust that makes sense. So we will prepare our pallet, and I'm going to bring the pallet back towards me. So we've got everything set for this stability test. Right, there we go. And I'm going to select 0.4 G. Now on this lab we can take tests from 0.3 G, which would be emergency stop from 18 miles an hour, right up to 0.8 G, which would be an emergency stop from a motorway speed in the UK. So it kind of encompasses the whole range of different tests that a pallet is likely to experience on the UK road network.
Okay.
So, right, Patrick, when you're ready, and we're going to get set with this test, and 3, go. Wow, okay. So we could see quite a lot of movement on that. First thing I'm going to do, UMOS states 3 things. That's to be a successful stable pallet, it needs to have stayed within 10% deformation, and we're going to touch on what that means. It needs to have stayed within 5% permanent deformation, and I will come back to that point. And there needs to be no visible damage, leakage to the pallet. So we're going to, first of all, go back in the chamber and we're going to have a look at the pallet. So we open the door. And here we are. This has just experienced an emergency stop from 25 miles an hour. There's nothing protruding from the side nor the front. There is no visible leakage. No cans of beer have been damaged in the processes of this test, which is good news. And actually all looks pretty good. Now we've come to a stop, all looks quite good. So now we're going to go and look at the data that the camera has grabbed from these labels whilst this test was in progress. So let's go and have a look.
So here I will show you the video of the test.
Now, not sure how well it shows on the camera. If you just play that again, please, Patrick. You can see the pallet leans right over it. This one actually goes right to 16%. So that test we just did has gone right over to 16% deformation. Now, as I mentioned earlier, UMOS states that it should stay within 10% deformation. That is the movement should be 10% or less than the total height of the pallet. So this has gone over that, which you may or may not have seen went red on the report.
So,
but it doesn't mean it's a catastrophic fail. So we're going to have a look at the pictures. Show us the first one, Patrick.
so yeah, so this is the initial picture. So this is as a pallet comes into the braking, and it's what you expect from the pallet, a fairly straight, stable look, and you can see the displacement there has gone to 1 centimetre, so the product has moved a fraction on the pallet, but other than that it's fairly straightforward what you'd expect for a pallet coming into the test.
That's good. So that was whilst the pallet was in movement before it started braking. Now we're going to look at the maximum deformation, which is whilst it's under its maximum G-force. So at the point this photo was taken, the G-force was 0.4 G, and you can see it's leaning across, and the deformation is 16%. Another interesting point to look at is the displacement. So the goods, so in this case the beer on the pallet, has slid by 2.5 centimetres between the pallet and the goods. And then we're going to look at the last picture we take, which is whilst the pallet is now stationary. So one thing to note is that it's come right back. So whilst it leant right across to 16%, it's come back to straight. And we can see deformation is at 1%. So in this case, the stretch film, whilst didn't hold it to the 10% that we wanted it to, it has performed in terms of bringing it back to keep a stable load. So this is quite typical to what we find. There's definitely improvements that could be made, and I want to just touch on why that's important, because if every pallet, if this on the back of a truck, you could have 26 pallets like this on the back of a truck, and if every pallet moved by 4 centimetres as the truck hit the brakes, the end one could move by over half a metre, and that is likely to then catastrophically fail at the back of the truck. So people often think about this and say, oh, but all my pallets are stacked in, they're all supporting each other. Yes, they are, but you've still got a 3 to 4 centimetre gap at the top of the pallet, and that room for movement is too much. So we would like to see this pallet staying much more stable, and we know that there's improvements that we could make to the wrap but we also know that it's unlikely to be causing safety issues. So it's within the boundary of reasonable safety. So our challenge really to our LinkedIn viewers this afternoon is think about your product, your pallets of products. What kind of levels of movement in transport do you get? How do you think your products would fare if we were to put this through this test that you've just seen today? Bear in mind we've only done a fairly gentle G-force test. An emergency stop at 25 miles an hour is nothing like the forces of an emergency stop at 50 miles an hour, for example. So our challenge really is, how would yours perform? And please do connect with us on LinkedIn. Obviously this is a LinkedIn live event. We love hearing from food and beverage companies, especially where there's pallet stability issues, that we can offer the services of this laboratory to help fix your issues. So with that, we've taken up our time. Thank you very much and enjoy the rest of your Tuesday.
Thank you.
Thank you.